Alright, so let's say you're given this diagram of an object under circular motion with the radius equal to 1 meter and the period equal to 2 seconds. And they ask you, what is the acceleration of the object if it has a period of 2 seconds? Would you know how to solve? If not, continue watching this video. So we can start off by analyzing the dynamics of circular motion. So if we have an object under circular motion here, the velocity is going to always be pointing tangential to the circle. The acceleration is always going to be pointing towards the center of the circle. In addition to that, the summation of the force is going to be in the same direction because of Newton's second law. As I note below, in uniform circular motion, net force and acceleration must always point towards the center of the circle. And the magnitude of a rad is constant, so that means that the net force is also going to be constant. And if you remember, the radial acceleration is given by this equation here. By Newton's second law to circular motion, we get F net equal to mass times acceleration radial. And if we plug in our radial acceleration equation, we can get this equation here for the net force. And this will be the net force on the object traveling in circular motion. But the question wants the acceleration in terms of the period. So we can start off by identifying that the period is the time it takes to complete one cycle around the circle. So if we remember, velocity is equal to distance divided by time, and then rearrange for time, we can apply this to our situation where time is going to be our period, distance is just going to be the circumference because the object's traveling around the perimeter of the circle, and then v is going to be equal to velocity, so we can plug this in, and then we can identify that the circumference of a circle is 2 pi r. We can replace velocity with just v. We can use this equation here to solve for the radial acceleration in terms of the period by plugging it into our equation up here. And so if we plug this in for the velocity, we get this expression here, and then we can compute the term on the top. We do a simple cancellation and get this final answer here. This is going to be the radial acceleration of an object in uniform circular motion in terms of the period t. And so we can apply this to our example. So if we just write down our equation and apply that the radius is equal to 1 meters and the period is equal to 2 seconds, we get this expression here. And then we can just compute the amplitude and the units, and we get this for the final answer. So this is going to be the radial acceleration of the object under uniform circular motion. And I just want you to notice that our units make sense. For acceleration is meters per second squared, and that's what we got. So that means that our equation we derived for the radial acceleration is a valid equation.